People often say space is freezing cold, but that's not quite right. Space is more like a vacuum than a freezer. There's almost nothing out there. No air, no water, hardly any molecules. On Earth, you feel cold because air steals your body heat. In space, there's no air to do that, so you wouldn't freeze instantly. Instead, your body loses heat slowly, mostly by radiating infrared energy, like a toaster cooling down. Imagine standing in front of an open oven. You feel the heat from the oven, not the air. Space works the same way. Objects get hot or cold depending on what's shining on them. In sunlight, things can get blazing hot. In the shade, extremely cold. It all depends on sunlight and surroundings, not air temperature. The real challenge is controlling those wild swings in temperature. On Earth, heat moves by conduction, convection, and radiation. Touching a hot spoon is conduction. A warm breeze is convection. Sunlight on your face is radiation. In space, only radiation matters. No air for convection, nothing to touch for conduction. Imagine a room with no air, just a bright lamp. You only get warm from the lamp's light. That's how satellites and the ISS handle heat, by absorbing and releasing radiant energy. In sunlight, you can get hotter than boiling water. In shade, colder than dry ice. No gentle breeze to help. Everything depends on light absorbed and radiated away. Spacecraft designers must carefully manage heat flow. They can't rely on air or contact, only on clever tricks with materials and surfaces. Reflecting, absorbing, and radiating heat are their main tools. It's a constant battle to keep temperatures just right. Satellites in the ISS face heat from several sources, with the sun being the biggest. Sunlight in space is much stronger than on Earth, since there's no atmosphere to block it. The ISS gets blasted with energy and sunlight, making surfaces extremely hot. Earth also gives off heat reflecting sunlight, albedo, and glowing in infrared. When the ISS passes over the sunlit side of Earth, it gets extra warmth from both. Inside, computers, lights, and astronauts all generate heat. The ISS constantly juggles heat from outside and inside. Balancing this is one of the biggest challenges of living and working in space. Temperature control is vital. Astronauts' lives depend on it. Too hot and they overheat, too cold, and hypothermia is a risk. Sensitive equipment can fail if it gets too hot or cold. Even the ISS structure can suffer if parts expand or contract too much. Imagine keeping hundreds of devices working perfectly, while temperatures swing wildly every 45 minutes as the ISS orbits Earth. That's why thermal control is a top priority. Without it, astronauts couldn't survive, and missions would fail. Keeping everything just right is the key to life in space. It's a constant, high-stakes balancing act. Spacecraft use two main types of thermal control, passive and active. Passive controls are like jackets, using materials and coatings to reflect sunlight or trap heat. The shiny blankets on satellites and the ISS, called multi-layer insulation, MLI, work like a thermos. They reflect sunlight and slow down heat loss, keeping the ISS from getting too hot or cold. Active controls are like fans and heaters, using pumps, radiators, and heaters to move heat around. On the ISS, water and ammonia loops carry heat away from hot spots to giant radiators that dump it into space. Together, passive and active systems keep the ISS in the Goldilocks Zone. It's a careful mix of simple and high-tech solutions. The ISS is a marvel of thermal engineering. Inside, astronauts live in comfort like a house on Earth. Outside, the station faces wild temperature swings every 90 minutes. Multi-layer insulation wraps the station, while water loops inside pick up heat from people and machines. This heat transfers to ammonia, which is pumped to giant radiators that release it into space. Electric heaters kick in if things get too cold. It's like having jackets, fans, and electric blankets all working together. The air stays at the right temperature and humidity, and equipment runs smoothly. Ground teams constantly monitor and adjust systems to keep the balance just right. Controlling temperature in space is a never-ending job. The ISS and its crew rely on clever materials, smart engineering, and constant attention. Every orbit brings new challenges as the station moves from sunlight to shadow. Without these controls, nothing would work for long. Thanks to shiny jackets, powerful radiators, and careful planning, the ISS stays safe, day after day. That's the real secret to thriving in space.